In this video, we're going to be doing some trees review. So for a binary tree, each node has less than 2 children and no ordering rule is going to be present. So here we can see that in each of these nodes, you're going to have 2 children maximum. This one has 2 children, this one has 2 children. This one is not going to be a binary tree because this node has 3 children. Now for a BST binary search tree, for every node, the left subtree values are going to be less than the node that you're currently at. And then for the right subtree values, it's going to be greater than the node that you're currently at. And there's going to be no duplicates unless specified because that means that it could not be on the left or the right. So here's an example. We can see that on the left side here, there's a division from the right side. Each of these values, they're going to be less than the one that comes after it. And then over here, each of these values is going to be greater than the one that comes before it. So you're going to search. So when you have a search here, you can discard half of it, and an in-order BST is going to be sorted. So for height, the length of the longest route to the leaf path is going to be the height of your tree. When you have recursion, your height is going to be, when your height is null, it's going to equal to -1. When your height of your leaf is equal to 0, you're going to just say that it's equal to 0. And when your height, when you're calculating your height, you're going to have 1 plus max, left height, right height. So for finding the max in a BST, you need to know that a max group means you keep going right. This can be iterative, and your iterative solution will look something like this. You're going to have while root dot get right does not equal to null. You're going to have root equals root dot get right. You can also have a recursive solution, and that's going to look like this. You would have return max root dot get right. Now, you have to be able to recognize some recursion patterns. First off, we have the height pattern. That's going to be when you have 1 plus max, left plus left, right, as we've seen. For leaf detection, you code this as checking if your left is equal to null, and also your right is equal to null. Also, you might have to code exists a node with property. So this pattern is going to be when you have something like a certain property at your root, or you have a property in your left, or you have a property in the right. Or you could have a case where you have a minor or swap pattern. So your temp is equal to your left is equal to your right, and your right is equal to temp. Let's write down some of the big O's that you have to know. So for balanced BST, search is O log n, insert n elements, this is going to be O n log n. Now for your worst case, BST, this is when you have a search of ON and your insert elements is going to be ON squared, and your tree traversals. They're always going to be O of n because each node is visited, once. So some recognition rules is if you have like remember that this is back to the definition of O n log n. Now, if you have one recursive call and goes down one side only, that's O of n. If you have nested loops over n, that's O of n squared. You might also encounter some things that pertain to stack versus queues. So when you have level order, this is going to be a queue, and a queue is FIFO. Now, if you have a preorder stored in stack, your last pushed is going to be popped first. If your preorder is pushed to stack, your final pop is equal to the last node visited. In addition, you have to be able to solve some expression trees. Key for these is you're going to have to evaluate them from bottom up. You always solve the children first, and then you apply the operator. And overall, remember that if you have the same values in a tree, it does not mean that it's going to be the same tree, because it depends on insertion order and traversals. Also, let's see here. In a BST, it's true that a search can discard half. Search can discard half. And remember that in order, BST means that it's sorted.